This is our Powering the World presentation. I'm Tyler Keene.
I'm Lucas.
I'm Jacob.
I'm Gabriel. And yeah. So the background, we're doing medical devices, and hospitals require large medical devices that require lots of voltage and lots of power, and so they're typically in three-phase. And then three-phase is just more stable for these large medical devices, and then so our power is generated off-site and then transmitted to the hospital, and then at the hospital it will be split into parallel circuits. So you'll see that next. So this is our power generator that would be off-site, and this is in delta form, so we had to convert that to star form, and then our transmission line that has some resistances to it, and that leads to our loads, which in our case is the air conditioning unit, some lights, and then like the outlets in each room, and then our x-ray machine that we're going to change later on to our own medical device. And again here, the air conditioning is in that delta form, so we have to change it for all of our calculations.
Awesome. So breaking down the circuit here in Multisim, we were able to take our values from there and analyzing the circuit. Like we were saying before, we had to convert some portions of it from delta form to star form. More specifically, the impedance from the source, there was a small resistor there and inductor that we had to divide by square root of 3 in order to convert it, as well as the AC, which we also had to divide by square root of 3. And then taking our values calculated for impedance, we have the simplified full circuit here that was able to give us our voltage up at the top there. We had, our current up at the top there. We had some issues with Multisim fully in this expanded form showing us the correct current, but when we go to the next portion of it and breaking it down and using our knowledge from circuits, we're able to add the resistors in parallel and series, bringing it down to a final total resistance right here, which as you can see gives us the RMS current of 17.5, which was equivalent to the total big circuit. So we correctly broke down the circuit into this form and overall was successful in that.
This is the MATLAB code that we did for this as well. We wanted to verify our measured value from Multisim with doing the hand calculations of it. We'll store the hand calculations. So we wrote just a code to take all the impedance values from all of the resistors and inductors in a one-phase diagram, and then we added them all up, sort of like what we did in Multisim, and then got the total current, and then took the magnitude of it. We found the measured from Multisim was a little bit higher than from the MATLAB, which was at 17.47, and the Multisim, as stated earlier, was around 17.5 amps.
Alright, so we selected the Lightspeed with Extreme CT scanner system. So this system has a current of 0.42 amps with a power of 53.2 kilowatts. The voltage that it has is 380 volts with a resistance value of 814.28 ohms and an inductor value of 7.872 hertz. Henry's, my bad.
You're good.
So the impedance value for this is given in that bullet point right there. That's the one in rectangular form, and converted to polar form, the magnitude is 904.42 ohms, and the angle is 25.84 degrees.
Sweet. And then just taking those values is just as simple as changing our X-ray from before to the Henry value that Lucas mentioned, and as well as the resistance values. And then we were able to see with the big phase circuit what the expected current value would be, which up at the top there, again, 17.5 amps was the expected current. And then breaking down it using our rectangular and polar forms, we were able to convert it into this phase, again, very similar to the circuit we saw before. Putting in our new resistance values, and we were able to calculate slightly higher than before, and that's just because we're dealing with completely different numbers. You'd have to think before the X-ray scanner had 220,000 ohms. This CT scanner that we found only used 904 ohm resistor in order to power the circuit. So we had an 18.3 amp value, but then going down to the final phase in Multisim may have some issues, but we got a 17.7 amps, which is very similar to the 17.5 for the big circuit, so we would overall call the breakdown a success.
And then once again, we verified this with some MATLAB code. All we did was change our Z X-ray value, which is the impedance of X-ray. We just switched it over to the CT scanner and left the rest of the code exactly the same. And the current for this time was 17.58, which is right around that 17.7. So a little bit of error percent again, but that's just to be expected with running two different things.
Alright, so for the Christian worldview of this project, Jesus says in Matthew 10 verses 7 and 8, "As you go, proclaim this message, the kingdom of heaven has come near. Heal the sick, raise the dead, cleanse those who have leprosy, drive out demons, freely you have received, freely given." So we are called to help the sick and poor among us, and the CT scanner will help in diagnosing so doctors can help those who need it the most.
These are our references and also where we got the values for that CT scanner. We were able to find a bunch of values and calculate for our total impedance. Thank you.
Thank you.
Thanks.
Nice.